Tokens. Tokens are the basic building blocks of a programming language and are used to represent various elements of the code. Tokens are often used by compilers and interpreters to parse and understand the structure of a program. Token classification. Keywords. Keywords are reserved words that have a special meaning to the compiler. Identifiers. Identifiers are names given to identify variables, functions, or any other user-defined entity. Constants. Constants are fixed values that do not change during the execution of a program. String literals. String literals are a sequence of characters enclosed in quotation marks. Special symbols. Special symbols are special characters that have a specific meanings to compiler. Operators. Operators are used to perform operations on operands, such as variables and values. Keywords. Void specifies that a function does not return a value. Int represents integer values. Float represents floating point numbers with decimal precision. Char represents individual characters. Byte represents an 8-bit unsigned value, 0 to 255. Bool represents Boolean values, true or false. If begins a conditional statement to execute code based on a condition. Else defines an alternative block of code to execute when the if condition is false. While creates a loop that executes code repeatedly while a condition is true. For creates a loop that executes code a specified number of times. Do creates a loop that executes code at least once and repeats as long as a condition is true. Switch evaluates different cases based on the value of an expression. Case specifies a value to compare in a switch statement. Break terminates the execution of a switch statement or loop. Continue skips the remaining code within a loop and proceeds to the next iteration. Return specifies the value to be returned by a function. Const declares a variable as a constant that cannot be modified. Volatile indicates that a variable can be modified by external factors and should not be optimized by the compiler. Size of determines the size in bytes of a data type or variable. Setup a special function used to initialize the Arduino board. Loop a special function that executes repeatedly after the setup function. In this code, the variable my_age is declared to be of type int and is initialized with the value 21. The keyword const is used to declare the variable as constant, which means that the value of the variable cannot be changed after it has been initialized. In this code, const int is a keywords. The include directive is not a keyword. It is a preprocessor directive that tells the compiler to include the contents of another file into the current file. Identifiers. Identifiers are names given to identify variables, functions, or any other user-defined entity. In C++, identifiers must begin with a letter, AZ or AZ, or an underscore character. After the first character, an identifier can be followed by any number of letters, AZ or AZ, underscores, or digits, 0 to 9. For example, my_variable, my_function, my_struct, and my_union. In C++, identifiers must follow certain rules. They must begin with a letter or an underscore symbol. They can be followed by any number of letters, underscores, or digits. They are case-sensitive, meaning that X and X are considered different identifiers. They cannot have the same names as C++ keywords or special symbols. In this code, the following identifiers are used. My_age. This is the name of a variable of type int. My_name. This is the name of a constant variable of type char*. Greetings. This is the name of a function. Constants. These are fixed values that do not change during the execution of a program. There are 4 types of constants in C++: integer, floating point, character, and string. For example, 1, 2.5, hello, and true. Integer constants are whole numbers that do not have a decimal point. For example, 1, 2, 3, 4, and 5 are all integer constants. Floating point constants are numbers that have a decimal point. For example, 1.0, 2.5, 3.14, and 4.2 are all floating point constants. Character constants are single characters that are enclosed in single quotes. For example, a B, C, and D are all character constants. String constants are sequences of characters that are enclosed in double quotes. For example, hello, world, and my name are all string constants. If you don't want others or yourself to override existing variable values, use the const keyword. This will declare the variable as constant, which means unchangeable and read-only. You should always declare the variable as constant when you have values that are unlikely to change. When you declare a constant variable, it must be assigned with a value. Another thing about constant variables is that it is considered good practice to declare them with uppercase. It is not required, but useful for code readability and common for C programmers. String literals. A string literal is a sequence of characters enclosed in quotation marks. For example, hello and world. A string literal is a constant value and cannot be modified. It is stored in the read-only section of memory. Single-line strings are assigned to a variable using single or double quotes. Special symbols. Special symbols are special characters that have a specific meanings to compiler. For example, comma, and hashtag. Punctuation marks are used to separate different parts of a C++ program, such as semicolons, winky face, and curly braces, and these marks are important for the proper syntax of a C++ program. The semicolon, winky face, is used to separate individual statements, while the comma symbol separates items within a list. The period symbol is used to access members of a structure or object. Parentheses are used to group expressions together, with the left parenthesis opening the group and the right parenthesis closing it. Brackets are used to access elements of an array, with the left bracket indicating the start of the array and the right bracket indicating the end. Finally, curly braces are used to define blocks of code, with the left brace marking the beginning of the block and the right brace marking the end. The hash mark, hashtag, is used to indicate a preprocessor directive, which is a special instruction that tells the compiler to perform certain actions before compiling the code. Operators. Operators are used to perform operations on operands, such as variables and values. Operators can be classified in the following groups: arithmetic operators, comparison operators, Boolean operators, logical operators, pointer access operators, bitwise operators, compound operators. Arithmetic operators are used with numeric values to perform common mathematical operations. Addition plus adds two values together. For example, x plus y adds the values of variables x and y. Subtraction subtracts one value from another. For example, y subtracts the value of y from the value of x. Multiplication asterisk multiplies two values. For example, x asterisk y multiplies the values of x and y. Division / divides one value by another. For example, x slash y divides the value of x by the value of y. Remainder % returns the remainder of a division operation. For example, x% y returns the remainder when x is divided by y. Assignment operator =, assigns a value to a variable. For example, x = y assigns the value of y to the variable x. Comparison operators are used to compare values. =, returns true if the two values are equal, otherwise false. For example, x == y returns true if the value of x is equal to the value of y. Not equal to is not equal to sign. Returns true if the two values are not equal, otherwise false. For example, x = y returns true if the value of x is not equal to the value of y. Greater than sign. Returns true if the first value is greater than the second value, otherwise false. For example, x greater than y returns true if the value of x is greater than the value of y. Less than sign. Returns true if the first value is less than the second value, otherwise false. For example, x less than y returns true if the value of x is less than the value of y. Greater than or equal to sign. Returns true if the first value is greater than or equal to the second value, otherwise false. For example, x equals y returns true if the value of x is greater than or equal to the value of y. Less than or equal to sign. Returns true if the first value is less than or equal to the second value, otherwise false. For example, x equals y returns true if the value of x is less than or equal to the value of y. Boolean or logical operators are used for conditional statements. Logical and returns true if both expressions are true, otherwise false. For example, x less than 5 and x greater than 10 returns true only if both conditions, x less than 5 and x greater than 10, are satisfied. Logical or returns true if at least one of the expressions is true, otherwise false. For example, x less than 5, x greater than 10 returns true if either condition, x less than 5 or x greater than 10, is satisfied. Logical not reverses the result of an expression. If the expression is true, it returns false, and vice versa. For example, x less than 5 returns true if x is not less than 5. These operators are used extensively in flow structures, such as conditional statements, if-else, and loops. They allow you to create complex conditions that determine the flow of your program based on multiple Boolean expressions. Bitwise operators. And sets each bit to 1 only if both corresponding bits in the operands are 1. Otherwise, it sets the bit to 0. Or sets each bit to 1 if at least one of the corresponding bits in the operands is 1. Otherwise, it sets the bit to 0. XOR sets each bit to 1 only if the corresponding bits in the operands are different. One is 0 and the other is 1. Otherwise, it sets the bit to 0. Not inverts all the bits in the operand. 1 becomes 0, and 0 becomes 1. 0 fill left shifts all the bits in the operand to the left by a specified number of positions. Zeros are filled in from the right. The bits shifted off the left are discarded. Signed right shifts all the bits in the operand to the right by a specified number of positions. The signed bit, the leftmost bit, is copied into the vacated positions on the left. The bits shifted off the right are discarded. These operators are used in various low-level programming tasks, such as bit manipulation, working with hardware devices, and implementing cryptographic algorithms. They can also be used to perform certain mathematical operations more efficiently. Pointer access operators. Let's discuss 2 essential operators used in pointer operations. 1. Reference operator and description. This operator is used to obtain the memory address of a variable. Syntax and variable underscore name. Example: ni equals 5, int asterisk p equals int I. In this example, ni gives the address of the variable I, which is then stored in the pointer of variable p. 2. Dereference operator, asterisk. Description. This operator is used to access the value stored at the memory address pointed to by a pointer. Syntax: asterisk pointer underscore name. Example: int result equals asterisk p. In this example, asterisk p accesses the value stored at the memory address pointed to by p, which is the value of I5. In summary, the AND operator gets the address of a variable. The asterisk operator gets the value at a memory address pointed to by a pointer. These operators are fundamental for working with pointers. Pointers allow you to manipulate memory directly, which can be useful for tasks like dynamic memory allocation and efficient data structures. Compound operators. Compound operators can be used with any of the arithmetic operators, plus, dash, asterisk, forward slash, and percent, or bitwise operators, and caret. These operators combine an arithmetic or bitwise operation with an assignment, providing a shorthand way to modify the value of a variable. For example, x plus equals 3 is equivalent to x equals x plus 3, both adding 3 to the value of x. Similarly, x asterisk equals 2 multiplies x by 2, x slash equals 5 divides x by 5, and x percent equals 3 takes the remainder of x divided by 3. Bitwise operators like and equals, and caret equals perform bitwise and, or, and XOR operations, respectively, on the value of x and assign the result back to x. These operators are a convenient way to write code more concisely and efficiently. Utilities. The progmem keyword in Arduino C++ is used to store data in program memory, flash, instead of RAM. This can be useful for storing large amounts of data, such as strings, images, or sounds. The progmem keyword in Arduino C++ is used to store data in program memory, flash, instead of RAM. This can be useful for storing large amounts of data, such as strings, images, or sounds. Size of. The memory size, in bytes, of a data type or a variable can be found with the size of.